Hi everyone. Since some of you just emailed me that they still feel difficult to follow the video without showing the operation of STATA. So I decided to record the part that I accidentally skip off during the video. So I hope this will help you, and I'm quite sorry for my mistake. So I think after the video, I think most of you have some understanding in t-statistics and also p-value. So below we are going to calculate it. So first we use the summary command to summarize the score and get the statistics that we need. So first, we summarize school, and then we use the return list and also scalar to restore the value that we need. For example, means, the number of observations, standard deviation, and also the standard error. And just like what we said in the last video, so to calculate t-statistics is to use the actual value, actual means that we get in the data set. So in this case, the variable mean score minus the hypothetical value that you think for the means of schooling. So in this case is 12, and then divided by the standard error of school. And then display it. So you can see that here, the t-statistics is minus 6.59. And since the absolute value of t-statistics, the absolute value of minus 659 is bigger than 1.96, so we can conclude that we can reject null hypothesis at 5% significance level. And also we can reject the null hypothesis at 1% level, since the absolute value of minus 6.59 is also bigger than 2.58. So just like what we said in the last video as well, and also on that picture. So the t-statistics is the value on the x-axis, and the p-value is the shaded area on the two-tailed side out of the position on the x-axis. So this is the relationship between t-statistics and p-value. So how we calculate p-value is try to find the shaded area outside the t-statistics. So since this is a two-tailed test, so we need to use 2 times normal, this comment. So this is try to find the shaded area under the normal distribution. And then minus absolute value. So ABS is the absolute value of t-statistics. And then we display it. So you can see that here, the p-value shows that it's 4.352 times 10 to the power of minus 11. So which means that if the hypothetical value is true, if 12 is really the true mean of schooling, then the probability that we get our actual value is only 4.352 times 10 to the power of minus 11. So which means that it's extremely unlikely. So as a result, then we can reject this null hypothesis at 5% level for sure, because it means that it's quite unlikely that 12 is the true mean of schooling. So this is how we understand the t-statistics and also p-value and how we operate it in STATA. So this is for the comparison with the one case, not difference in means, because 12 is a certain number, but rather than another group, the mean of another groups. So, and then next, we are going to test the hypothesis that the average years of schooling is the same for men and women at 5% significance level. So to do this, actually is similar with the last case, but now we need to get the statistics for both groups, so both men and women. So first, we need to get the summary statistics that we need for females. So we actually operate the same commands, summary, return list, and also scalar. And then we do the same thing for males. So we summarize school based on male. So male means that the dummy variable female should be 0. And then return this. And then scalar mean male, right? Equals our mean. Scalar and male equals r n. Scalar variance of male r variance. And then we use the same scalar command to calculate the standard errors. And actually, this standard error is the same way that you calculate the standard error for confidence interval. So actually, they are consistent. So you can see here, how you calculate the standard error is the same. So you use the variance of male divided by the numbers of males in the data set, plus the variance of female divided by the numbers of females in the data set. And then you add them up and put a square root here. And then we calculate the difference in sample means. So the difference in sample means is that the difference of means of schooling between men and women. So which means that is mean male minus mean female. So to calculate the t-statistics is the same. So it's the actual value minus the hypothetical value divided by the standard errors that you get. So here the actual value is school gap minus the hypothetical value. So the hypothetical value is 0 because we test the hypothesis that the average years of schooling is the same. So the hypothetical value should be 0 in this case. And then we divide by the standard error of difference. Yes. And then we display it. So you can see that now in this case, the t-statistics is only 1.779 here. So actually this value, the absolute value of 1.779 is the same as 1.779. So which is smaller than 1.96. So it means that we cannot reject the null hypothesis at 5% level, because it means that based on our assumption that the true mean is 0, the probability that we get the probability that we get the value, like the actual score gap that we calculated, is actually higher than 5%. So that we cannot reject this null hypothesis at 5% level. However, we can reject it at 10% level because actually this t-statistics is greater than 1.64. So we can reject this hypothesis at 10% level. So to see that, what is the exact level of significance? So which is, again, the shaded area that we just set and show in the picture. So to answer this, then we can calculate the p-value. So it's still the same as the last case. So we use scalar to calculate it and also display it. So it shows that it is 0.075. So which means that if our assumption that there should be no gender gap of schooling is true, then the probability that we get this actual value is 7.5%. So maybe you feel that it's a bit counter intuitive that there is it's not that likely to have the gender gap of schooling in this case, since we heard it a lot from news and also maybe from what you learned. But this is just the result based on this data set. So it can be affected by how this data set is collected as well. So even that the result is not significant enough, it does not mean that it's definitely wrong. So this is for the hypothesis testing part. And then now we are entering the part of regression. So regression is try to find the relationship between, for example, wage and female, or like wage and education. So for example, now we want to estimate the following wage equation, just as the screen shows. So we want to know that what is the relationship between wage and female. So in this case, so female is like the familiar dummy variable. So which takes value 1 if observation is a female and 0 otherwise. So how we run the regression? Actually, it's extremely straightforward in STATA. So you just write reg. So reg is the abbreviation for regression. And then you write female. Oh, wrong, sorry. So you write wage and then female. So the first position is always the dependent variables. So which is also on the left-hand side of the regression equation. And then after the first position, the second position should be the independent variables or the mean variables that you are interested in. So for example, in this case, it's female, then you put female in the second position, and then you just run this regression, and you can get the results of regression that you would like. So for example, you can see here, there is numbers of observation and t-statistics here, a p-value is here, the coefficient, so which is also the beta in the do file, and the standard error, and also 95% confidence interval. And the cons here means the intercept, so which is the alpha here in the regression equation. So after we run a regression, how are we going to restore the value that we get from regression if we would like to use it? So again, we use scalar to do it. So we use scalar to do it. So we, for example, if we would like to restore beta, so which is the value here. So we write underlined B and then bracket female. So why we write underline here is means that like it's the regression, so we need to restore the value, and then female. So for alpha, it's the same, so we also write underline B and then bracket and then the constant. So remember that you also need to put an underline in front of the cons here. So this is just the variable names. And then to take out the standard error, then we need to write standard error and then the variable name female. So after we operate this and then we display. So if we want to display the gender wage gap, so which is here, minus 17.52, because this is the wage difference depending on your gender. So which is also beta in this case. So we display beta. So you can see that the gender wage gap is minus negative 17.52. And then if we would like to display the average wage for men, then we should show alpha, so which is the intercept, because beta means that the difference between the difference of wage between men and women. And especially it means that if you are a woman, what's the difference? So which means that the intercept should be the wage of men, because beta means the effects of female on wage. So if you would like to check whether this idea is true or not, then actually you can use the summary command that we learned before to check whether the average wage for men is really this number, which is 88.75. So if we would like to check it, so we just operate, execute the summary wage if female equals 0. And then you can see that here, the mean is the same in these two cases. So which means that the intercept is really the wage for men. And last, we display the standard error for beta. So you can see that here is 1.1088. So which is the same as here, 1.1088. So this is how we extract the value from the regression command. So now we know that the average wage for men is the intercept. Then how about the wage for females? Reasonably, then it's alpha plus beta, because alpha is the intercept, um, meaning the wage for men, and beta means the gender wage gap, so it's the effect of gender on wage. Then the average wage for females is reasonably alpha plus beta. So how we calculate it is use alpha plus beta, and then we display it. So again, if you feel a bit doubt about this value, you can check it by using the summary wage if female equals 1 to see that whether the average wage for female is really 71.23, which is this number. So when we check it, then you can see that actually they are the same. So the reason why here shows that 2319 rather than 2318 is that in the summary, it will only show the 4-digit. So the STATA just make it from 23189 to 2319. So of course, you can also use male as a dummy, just as what you can use a male as a dummy, but the wage difference between men and women is the same, but the regression will just change the sign. So which means that since since the original regression equation means that if you are a woman, then your wage tends to be lower than men. So now if you use male as a dummy, then it's turned to emphasize that if you are male, then your wage tends to be higher than female. So if we want to use male as a dummy, then we should generate the variable male. So how we do that is we first use the generate command and then replace the value. So we generate male equals 0, and then replace male equal 1 if female equals 0. So which means that if the value of male is 1, it should be that the same observation should take value 0 in female, which is also quite reasonable. So by this process, then we create the male dummy variable. So now we run a regression between wage and male. So you can see that now it turns the sign from minus 17.52 to positive 17.52. So we can run the regression between wage and female directly afterwards. It will help us compare. So you can see that male here is positive 17.52, And then female here is minus 17.52. And in the male part, the intercept shows the wage for women because this is the comparison group. And in the female as a dummy variable, the intercept, the comparison group, is the wage for females. So this is the difference between using male and female as dummy variables. But basically, the idea is similar. So the one that didn't show in the regression is the comparison group. And the one that you put is the one that you would like to emphasize. So this is the case if you use if you use male as dummy variable. And then of course, we can also, we can still construct a hypothesis test of the beta coefficient for female being statistically significant, different from 0. So we can also do a hypothesis test on beta as well, not only means, but also beta. So the null hypothesis that is beta should be 0, which means that in this case, there is no gender wage gap. And the alternative is that the gender wage gap is not equal to 0. So we calculate the t statistics. It's the same. So it's to use the actual beta minus the hypothetical value of beta. So in this case, since we hypothesize that there is no gender wage gap, so the hypothetical value should be 0 in this case. And then we divide it by the standard error of beta. And then we display this. So we can see that the t statistics in this case is quite small, so which is negative 15.80. So this is how we manually calculate the t statistics, but actually the regression command already help us get the t statistics, just as what I said. So if you run the regression again, you can see that it's already here. The t statistics is minus 15.8. So which is the same as here, minus 15.8. And then now, if we would like to calculate the 95% confidence interval manually, so actually, just as the t statistics, so actually, by running the regression command, we already get the 95 confidence interval here, just as what you see. So the 95% confidence interval for gender wage gap is between negative 19.69 and negative 15.34. So if we would like to confirm this result, we can calculate them manually. So it's the same as what we just learned last seminar. So it's beta minus 1.96 times the standard error of beta. And then the upper bound is turn the minus sign to plus sign. So it's 1.96 times standard error of beta. And then we display it. So you can see that actually they are the same. So the lower bound is minus 19.69 here, minus 19.69. The upper bound is minus 15.34, the same here, minus 15.34. So this is the part of hypothesis testing and also regression. And then the last part is talking about um, the most important assumption in a regression. So before going to this part, so I need to say, I think the most basic, but also the most important thing in statistics is that relation does not imply causation. So A and B is related. Does that mean that A must cause B or vice versa? So maybe they just correlated with each other. So if you would like to interpret the result of regression as like causal relationship, so for example, in this case, if you would like to interpret that female is the reason of the gender wage gap that we see, then you must fulfill an assumption. So in this case, is female should be uncorrelated with the error term. So which is the thing that does not shown in the regression. So for example, because in this case, we only run the regression between wage and female. But for example, we didn't put education, family background, or like marriage and other things else. So which implies that if we don't put those things, which both correlated with female and a wage, then actually the true relationship between female and wage can be affected by those variables that you don't put in the regression. So those variables that might affect the regression result between female and wage in this case is called omitted variable. So which can affect the result of regression if you would like to interpret it as the like causal relationship, not only the like related relation, related relationship. So this is one, I think the most important reminder when you try to interpret the thing that you see after you execute the regression command. And to make the things like more correct to interpret, so we can put those like variables that we omit to recover the relationship between wage and female. So for example, in this case, we can put education in the regression command to control the bias in the regression function. So to run the multiple regression is also really straightforward. So you just put the variable after the other variables. So in running the regression, always remember that the first position is always the dependent variables. But after the first position, they are like always like other independent variables. So for example, now since our focus is the relationship between wage and women, and schooling is the omitted variable that might affect wage and women at the same time. But since our focus again is the relationship between wage and women, so school is the variable that we control the bias um, between these two variables. So in this case, we call like schooling or education as the control variable. So actually, which variable is control variable depends on which relationship is the relationship that you would like to look. So for example, now, if you would like to know the true relationship between wage and schooling, and then women now becomes the control variables because women now is both related to schooling and wage. But since your focus is wage and schooling, so women is to control a bias between these two variables, then now women becomes the control variables. So it's not necessary that which variable is definitely the controls uh, or like which variable are definitely omitted variables. So it all depends on what is the things that you really want to look at. So this is also related to what you are going to do in the term paper. So in doing the term paper, you should first think about what the things that you should focus on, and then what are the omitted variables that might affect the relationship between the two variables that you really would like to take a look. So I would talk about this issue afterwards more deeply, since causality and also the omitted variable is, I would say that is the core part of modern econometrics. So economists try very hard to solve these problems because actually in the reality, we know that it's quite difficult to fit the assumption that the regressor, the independent variable that you would like to take a look, has no relationship with error term at all. It's almost impossible to fulfill unless you directly run an experiment. But other than that, it's almost impossible. So I would talk about this more deeply afterwards. And yeah, so now basically this is the end of the STATA part, and I'm sorry for accidentally um, hit the screen for the STATA operation. So that's why I record this part of video again. Yeah, and thank you.